Hey, right now we're going to go over in Mathematica how to do graphing. So, and just like if you already learned the basics of Mathematica, this is actually going to be really helpful. I just learned the basics like earlier, and so I guess a very basic thing is that to make like these headings or these titles, you would go to Format, you go to what style that you want, and then title. So this one specifically is the title, and there's a couple of things right here that those are for sections, different sections. But while you're in it, you see how my mouse is a little sideways. So what that means is that that's where I can type. I can type right under it, and it's going to be in this specific section. It's only going to be under the title section. This will be under the simple graph section. This will be in the different style. And these are the different subjects we're going to go over here today. So something really helpful, by the way, that I noticed is if you go to palettes and you go to the basic math assistant, there's a whole bunch of things in here that everything that you basically need. So you don't have to go through the hard way, go search up how to find theta. You don't really have to search up like this, getting that symbol, that Greek letter, and then copying it and pasting it. That's what I used to do a lot before. So yeah, you could just copy this and then paste it in. But something nice right here is this legit right there. And it goes in. That's a really nice thing about it. So that's something cool about it. There's a lot of other cool things that I'll be using as we go through. So remember the basic math assistant. Alright, cool, sweet. So for graphing, if you learned before, you can type an equation like 2 plus 2, and when you press Shift Enter, it's going to compute it for you. So it's going to be the exact same thing with graphs. So let's try like a simple graph. Let's say, for example, we want a graph x cubed, and we want it to be between -5 and 5. So we want it between there. Now I'll show you how do we do this. So this thing, you think of it like we're like the king or we're like the queen of the land. People have to do what we say, but the thing is we got to be very specific with our orders. So that's exactly the way what this is, and we got to do it in the language that we have it. So say we're in Spain, we want to become the king and queen, we got to speak Spanish. If we want to be the king and queen of America, got to speak English. So this is very similar, but there is a different language that we use here in Mathematica. So for this one, if we want to make a simple graph, what we would need to do is write plot. But you got to make sure that it's capital P to start out with. That's what they really need for almost everything that you'll do. They're going to ask for a capitalized first letter. So this one, for example. So when you type something in, it will show different options of what you could do. In this case, we're going to do plot. But something cool about Mathematica, you can see if you did something else or if you messed up, it will turn blue right there. And that means that it's not anything that it doesn't recognize anything like that. So this one, it does recognize plot. Now, I'm going to do the square brackets. And inside the square brackets, we're going to do everything, and whatever's in it, that's what's going to plot. So if there's something on the outside, it won't take that into care. So what we'll do is we're going to start with the function. So what this one is y equals x cubed. So what we'll do for this is we'll just put in x cubed. X with the caret 3. And then what we're going to do for that, so that's what's going to the graph. But now we're going to need some bounds. Like, what is the graph going to look like? Is it going to be -1,000 to 1,000? Is it going to be -3 to 3? But for this specifically, we want to do, negative 5 to 5, like we mentioned right here. So the way that we'll do it, anytime you edit the graph in any way, so like edit x cubed, you're going to want to do these squiggly lines right here, these squiggly parentheses. So for that, and now we've got to do the variable that we're going to use, so x, and the bounds between that, we want it to negative 5, comma 5. So it's pretty similar to a calculator. Yeah, that's what we usually do if you want to solve anything on a graphing calculator. That's the best way. So that is legit how you do it. And all you gotta do, kind of like we computed up here, like 2 plus 2 equals 4, we're going to be doing Shift Enter, exactly like it. Sometimes my my computer's a little whack. Shift Enter. Oh, actually, look at that. That was exactly the problem. You see that? So sometimes it'll show that there's a problem. And what it's saying, it says it has no closing bracket right there. So that's what we need to fix. And you see how that's in red? That's a perfect learning experience. So now it's all cool, everything's good. There's no blue words, and the x's, that's just a variable, so we can leave that be. Now Control Enter. No, Shift Enter, sorry. There we go. Awesome, so that's legit it. You see how it's between negative 5 to 5. That is what x cubed looks like. So this is how we can see it in a very accurate way if you want to keep it like that. Cool. And so now we can make a completely new one. So this one can be for you to practice. So what we want, let's do an equation of 3x squared. And then we want it between negative 6 and 6. Okay, cool. Alright, awesome, cool. So that should be enough time to do so. And if not, you can pause it. But this is exactly what it'd be like. So we're just like that, just like we did above. Do the equation first, comma. We need the squiggly lines because that's what the graph is going to be with x values between negative 6 and 6. That's what it's going to look like. Alright, cool. So now we're going to be doing something a little similar. So we're going to be making a graph like this, but this time we're going to change a couple of things about it. I mean, that's kind of a plain blue. It's like, it's kind of okay. It's kind of weird, but we'll go over and making a different style. So now let's try doing it. Let's try making another graph. Under tangent, and you gotta make sure that you're gonna do it over a capital T, just like we did before, and just like we mentioned, it has to be a capital T. And unlike you've done before, when you write in class, we're not going to use parentheses. We're going to use the brackets. So now what we're going to want we're going to want tangent of x. And this time, we want it to be in the interval of negative 2 pi. And this is the interesting about this. So in Mathematica, do you remember how we went a little bit earlier to the basic math assistant? So rather than typing pi, because you saw that I was blue, that didn't work. So if you go to palettes, you see there's pi legit right there. So if you want to use it, there it shows up. So we want to do this from negative 2 pi to 2 pi. I say, I kind of feel lazy. We could actually use, remember, the capital PI. And look, it's right there. And so either way works, it doesn't matter. And so now we got the close brackets. And what we're going to want for this is we're going to want this not blue anymore. We want to make it black. And what we also want to do is make it dashed. And that's going to be really helpful in the future. And so to make this one different, you see this word style? That's exactly what we're going to do. So, but now we got to edit it. So just like we got the comma, capital P, O-T, plot, and then you saw style right there, plot style. And what's going to show up, if you decide to type it out, but if you click that, it's already going to show an arrow. But what you can do is you could do a dash, and then this, and that's what's going to make the arrow already. And so now we want it into this. You see how it changed already? Now to edit this, we're going to want to do, we want to make it black. Make sure to capitalize it. We want to make a dashed line. The cool thing about it, it already has all that in there. And so now, before I forget again, got to close it all off. So that's it's complete. And there it is. You can see how it's from negative 2 pi to 2 pi. You can see how it's dashed. It's black, not blue, not solid. And that's what makes it a different style. Now this one is just for y equals something x equations. Now what we're going to want to do, we're going to want to go through hyperbolas and circles, because this is a lot of what we're going around in chapter my multivariable calculus class. And we're going over hyperbolas and circles. So this one, you know how that's you can see in different equations like y squared plus x squared equals 1. That'd be a circle. Move over here. This is a good thing to look at. So I made these graphs. These are what a circle looks like, and 2 hyperbolas, what these are going to look like. So for an x squared plus y squared equals 1, as we know in previous classes, that is a circle with a radius of 1. With the difference between this, so x squared minus y squared equals net 1. It's going to look something like this. It's going to be on this side. And this circle in this box and these dashed lines are used for help for making this. These dashed lines are actually asymptotes. So these lines will never touch it, these blue ones. And same thing with y squared minus x squared equals 1. So this would be a good thing to write in your notes if you haven't already. So it's easier to memorize, easier to see. Very cool, but let's start with the circle. So the way that we're going to want to do that, go under the hyperbola/circles section. And the thing, we can't really do this as a plot, because that's just a y equals something else. So this one will be, we'll make it a contour. A contour. Plot. There we go. Cool. And now this one makes you able to use multiple variables, which is nice. So say we do, remember like we said, x squared, and that plus y squared. And I'll make that equal. But the thing with Mathematica is we need to make it to 2 equal signs. And that will equal, we want to make it equal 1. Cool. So just like we did beforehand, we got to make the bounds. And so let's say if we want to make it between -3 and 3. So similar fashion. So make it x between -3 and 3. Cool. And now since it's not just an x, there's also a y involved. We also want to make sure that the y is being taken care of too. So we do a comma, another edit. We'll make the y be between -3 and 3 as well. Then it's finished, and then comma. And let's make this one the style as dashed, just a dashed line. Like, doesn't matter the color, we'll just make it dashed. So with this, it's a little bit different. Since it's not a regular plot, it's a contour plot. So this one, what we got to do, gotta have the comma, and then the editing tool again. Let's do contour style right there. And the arrow is already there, which is nice. So we want to make it dashed. A dashed line. And that should be it. And that should be the plot. Just gotta put that in there. See how there's no blue marks except the variables. Shift Enter. It should be popping up right there. That's exactly what I want it to look like. If you think of before, remember how it's like that? It's legit a circle right there. Okay, cool. So now let's try a different one. Alright, cool. So we got that right there, which is nice. Now let's do a hyperbola. Cool. So say if we want to make it with the equation of x minus 2, that squared, and what that minus y squared, and make that equal to 1. Cool. Now let's go over how to do it. And you could pause if you want to practice by yourself first. Sweet. So now this one, gotta do it again. Contour plot. And then let's do this bracket. Now we gotta do this. So x minus 2 squared. That minus y squared. Make that equal to 1. And you can already kind of picture, if you know a lot about hyperbolas, but say if this was a x minus 2 squared plus a y squared, that would be a different ellipse. So that would be, it'd be kind of like an oval in a way. So it's going to be shifted because, actually no, it's not divided by, so we're good. Sorry, disregard that. So let's just do it like that. And now what we want for this, let's do a comma. We want to adjust it so it's going to be in between -3 and 3 on both the x and the y. And how about we make this a red color? Let's make it a red color. Cool. So we gotta do, just go to x, -3, 3. Another comma, and what we wanted to do for the contour style. Let's make it a red. Remember to capitalize it, that's super important. Right, red, and we finish it off. So let's check and see what this looks like. Yep, there we go. That's the nice thing about it, and the only thing that's different about it is that it's a little bit shifted. So just shift it to the left. No, to the right, too, actually. Awesome, that's what it's like right there. There we go, that's what we're specifically looking for. I accidentally put the thing up there, which would make sense why it's that again. So this is what it looks like, but say we want to have both things, because it looks like we're missing both of those. So now it's only to 3 right here, but you can see how it's at -1. So how about let's make it between -5 and 5. And let's see if we can make it 5. But let's see if that makes a difference. Yeah, there you go. You can see at least part of it. And this is just a repeat from up here. Cool. And if you want to adjust it, you can. You can make it to even farther over here so you can see the exact thing. But that's something that you can do in your own time. All right, awesome, cool. So now we just went over that. Now, let's start making a hyperbola with asymptotes. Because as we've seen in pictures before, we've seen in these asymptotes right here, right there. Kind of like that. So those ones are a little bit more trickier. So what we got to do is, this is a little bit more extensive. So something that I've noticed is if you want to find the asymptotes, I mean, we don't really have to do it by hand anymore. I mean, we're in a pretty high level math class now. So I just went to a calculator online. So if you go to this right here, symbolab.com, there's a way that you can use the functions, you can go to hyperbola, and you can actually find the asymptote itself through here. That is a really nice thing right here. So let's take this equation right here. So 1/5 x minus 1 squared minus 1/9 y minus 2 squared equals 1. So we can see how that's basically like an x squared minus a y squared equals 1. So that means it's going to look something similar to this. But it's going to be shifted because of all the numbers. Alright, cool. So let's keep that in mind. So that's what it's going to look like. And because we're going to make it look like the asymptotes are going to be completely different lines, there's going to be 3 plots. There's going to be 3 different things. So we can't just use one counter plot. We got to make it a way so we can see more than one. So 1, 2, and 3. Basically 3. So let's go to hyperbolas and asymptotes. So what we're going to do, the thing that's different about now, the way to make it so you can see every single one instead of just one, is you got to start out with show. So you command, you're the king, you're like, show me this, show me all this. And now we're going to do a lot of work around here. So we're going to do contour plot. Now let's go over the first one. Let's go over this, just this one for right here. But we'll do the different equations. So the one that we saw up here. This one is a little more extensive because it has all these things. So now we got to make sure to write all of this right here. So let's look at that. 1/5 contour plots. This one, start with a bracket. So 1 divided by 5, and it was x minus 1 squared minus 1/9 times y minus 2 that squared. Make sure that a double equals 1. So that's what we want to graph right there, that specific one. But let's make this bounds between, because there's a lot of high numbers, let's make it between -20 and 20 for the x values. So go in here. So x, -20 to 20. And we finish that off. Now let's go to the y. A similar thing. We do -20 to 20. And now let's make this one also red, because we want to make sure that there are 2 different colors, the asymptotes and compared to the regular hyperbola, just so we can see the difference. And so let's make this one red. So go to edit, let's go do that. Actually, So now we're good with that specific one. Awesome. Now we want to make sure that we do the asymptotes. So let's look at the equations. So when we search this, that's what it was. When you scroll down here, it gives the equations right here, the properties. So here, these are the equations for the asymptotes. So those are these lines right here. That's those equations. So let's do that. So 3 over the square root of 5 times x minus 1 plus 2. Let's do that one first. So see how we're in the show. So now we just finished this one. Now we gotta do a comma. We gotta do another contour. Oops. Make sure both are capitalized. Now let's make this one. Since there needs to be both variables, again, we'll keep the y now. So y equals 3 divided by, now here is where the basic math assistant comes in handy again. So remember how I don't really see something on my keyboard for a square root sign. So we could do right here, it's right there. 3 square root, make sure to click on that. Thing is with that, you gotta click tab so you can actually go inside. So as you can see before, it's going left or right. Make sure it's in the tab. Tab will go inside. So this one, 3 divided by square root of 5. We want to do that times x minus 1 plus 2. As you can see, yep, right there. And we want to make that one. And we could just do the same bounds between all of them. So you could just, I would just copy this. I can paste. So we'll do that. And we want to make this one a dashed line. So it's already going to be a different color because this one will be, the first one will be red. So it'll automatically be a different color, which is nice. So contour style, make it dashed. Let's finish this off with a bracket. Oops, daisy. Make sure we got everything right. Okay, cool. And now what we're going to want to do, we do the third one now. So it's going to be pretty similar to this. So what I'm going to do, it's going to copy this whole thing. Just want to make it. I'm going to make another one. Awesome. And with this one, the equation is just barely different. You see how it's just a negative right here? That's all that's different. Let's add a negative right in front of it. Negative. Cool. And the same thing, it's going to be dashed. It's going to look good. It's going to look pretty prime. And see if there's any mistakes or anything. I think we should be good. But looks like this one, we need to finish it off completely. There we go. There's nothing changed. Let's see, there's error. Cannot be followed by an equals. There we go. That's what made it upset. There we go. And that's exactly what it'll look like. So now that you guys have seen how we can fix things, that's going to be very helpful for when you do, because I make mistakes a lot. And as you can see, it's perfect. It never physically touches it in the eternities. straight line, dash. So these are the asymptotes. That's what we're talking about. So yeah, and this is also how you go through the problem on 2.18 using Mathematica. And this is the equation right there.